Today I'm going to give an investor presentation on behalf of Lightwave Logic at the Ladenburg Virtual Technology Expo for the 18th of November 2021. I am Michael Lebby, the CEO of Lightwave Logic. This is our safe harbor slide. And so a quick overview of Lightwave Logic. We've had a good couple of months. We were successfully uplisted to NASDAQ on the 1st of September 2021. We did a very unusual organic uplist, i.e. we didn't do any reverse split and we didn't raise any money on the uplist. In the meantime, we've been invited to speak at many investment conferences, as well as international technical conferences on our technology platform. As you can see from the right-hand side, we have a very strong balance sheet, and we're looking to strengthen that now that we're on NASDAQ, so we can accelerate product to market. And we have an extremely strong IP and patent position, including a phrase that I term freedom of manufacturing, which is very important in today's environment, and it's a very strong phrase too. You can see from the financials on the right-hand side, we have a very strong balance sheet, and we're headquartered in South Denver, just south of the tech center in Englewood, Colorado. This is what ringing the bell at NASDAQ looks like on the 10th of September, 9 days after we uplisted. It's sort of a very exciting time. And when you actually do get a chance to press the button, as we did in this slide, you can see there's tons of energy. So closing the market at the end of the week on the 10th of September at 4 p.m. East Coast time was actually quite exciting, as you can see from the photograph. In terms of who we are and what our impact is, we are a technology platform that is designed to scale the internet infrastructure by providing transmission of data at much higher speeds with much less power. And this is essential for the fiber optic data communications today. We do this by leveraging our proprietary electro-optic polymer materials to create photonic devices. We have technology evaluation underway, and we have in-house control of material supply, device fab, and package design. And so the impact here is the faster internet with much lower power consumption. So let's have a quick look at the applications and markets. So we solve headaches for the internet. And this is a very simplistic slide that shows you that the fiber optic network, the internet, is composed of a network of fiber optic cables that send signals, the ones and zeros of the digital data across the network. And this is similar to what we do when we're at home looking at a video platform and we're sending signals to websites or even communicating with family across the world. The internet actually has these optical pipes and they carry data between the end users. Now, the problems and the headaches are that the experts, the industry experts, agree that there is some radical innovation is needed. And our photonic devices are the radical innovation the internet needs to send data faster and at lower power. And so when we look at the metrics of the internet over the last few years, you can see that the traffic growth, this is the data that we send as users of the internet, is increasing at a fair clip. You can see the Cisco Global Cloud Index graph on the right-hand side, showing you a 25% compound annual growth rate. And so we can see from my comments on the left-hand side, there's been an exponential rise of consumer level data usage, and especially in the last 2 years of the pandemic. And the network capacity is actually falling behind the traffic growth. And if we look at the second bullet, the network cost and energy consumption have become the new hotspots for the data providers. So these are the issues that need to get solved. And our polymers, our technology platform, as you can see from the takeaway at the bottom of the slide, can transform the internet with much better performance. And so quickly looking at some of the markets for photonic components, you can see as you look out over the next decade, these are huge markets with huge opportunities. And the fiber optic transceivers, part of the photonic component segment, are a perfect vehicle for hybrid photonic gate array circuits. And this is part of the technology platform. And you can see this is going to be 2/3 of that market by 2030. And so fiber optic transceivers and modules are expected to explode over the next decade. So it's a great opportunity. And in fact, if you look at the photonic markets, what I just talked about was fiber communications, high performance computing, computational data center. You can see at the lower 3 lines of this graph, these are existing markets. We've also got fiber optics in the backhaul, and we all know that 5G systems is growing very quickly today. But the other things on this slide, if you look out of the forecasts of the standard market researchers over the next decade, I mean, there's other big opportunities that are really growing, like automotive and LiDAR. You can see medical instrumentation, and see these are great and exciting areas for photonics as they grow over the next decade. In fact, in terms of our proprietary electro-optic polymer technology, we are starting with fiber optic communications. But as you can see, our technology can be extended to more applications. We use less power. We can increase the data throughput in the network infrastructure. And we do this by using ultra-fast optical modulators. Optical modulators are optical devices that switch light very, very quickly at low power consumption. And you can see from the bottom right-hand corner of this slide, there's other opportunities outside of fiber optic communications that are looking really exciting, such as LiDAR, automotive, sensing displays, etc. This is where light needs to be switched very quickly at low power. So our polymers enable faster devices and lower solutions today. And our competitive advantages are shown in by 3 very simple graphs in this slide. We can actually have impact with energy savings on the network. On the left-hand side, in the center, we can enable faster networks. And on the right-hand side, we have a great engineering advantage because our platform flexibility in being able to design and optimize our own polymers ourselves in Colorado gives us that flexibility to actually have the big impact into the marketplace. So our technology addresses the customer pain points that are facing network operators today. And so in terms of targeting customers, you can see we could have direct sales into optical component suppliers, high-speed optics manufacturers, and network manufacturers. And we are talking to those folks today. You can see that the market is actually influenced by the internet service providers, and even some of those guys are interested in the optical components. So we have the potential to enter the market in many verticals, and we are talking to these folks today. And in terms of the business model, you can see what we just talked about was a classic business model of selling components. But in today's environment, you need to have the flexibility of a multi-pronged business model that allows you to license technology or even look at technology transfer. And this gives us, these 3 prongs gives us the flexibility to engage with all different types of customers up and down the value chain. And I think today's environment, you need to be flexible and you need to be able to do that. But in order to be able to do that with confidence and to do that with success, you've got to have a very strong IP portfolio. So let's talk about intellectual property and patents. And in terms of our intellectual property portfolio, it is actually quite robust. We have over 70+ patents and patent applications. And I've underlined here freedom of manufacturing. Freedom of manufacturing is extremely important. It means you have the confidence to manufacture your technology platform. And in fact, if you look at what we're focused on in our patent portfolio is tech transfer to large silicon foundries, licensing royalties, OEMs, contract manufacturers, communications customers. And we've even strengthened our patent portfolio by acquiring Lumera and Gig Optics patent portfolio and their know-how a couple of years ago, and we gained 15 patents there. So we put together a very powerful patent portfolio with freedom of manufacturing for electro-optic polymers. So in terms of technologies, Now, this is a very complicated slide, so I would encourage you to look at the slide after this talk. But you can see on this slide is a 3D graph, it's a technical graph, and in the green dotted lines is like a wall. I've labeled it the wall. On the far side of the wall is where commercial optical devices are today. You can see I labeled that in red, where we have shown the performance of our polymer modulators are actually breaking through that wall and moving to the right-hand side of this slide. So you can see from those green boxes, polymer modulators and faster polymer modulators, we have the headroom with our technology platform to go much, much faster than the competition. And you can see some of the data rates on the right-hand side. And if you start looking at those, the takeaway from this slide is our polymers are typically 3 times faster than competition today. And this is really exciting. In fact, this is what a polymer modulator chip will look like using a polymer stack. And this is fabricated on silicon wafers. And so this is just to show you where the light goes in and the light goes out. And this slide is showing you that we have natural integration with big silicon foundries. The polymer stack is the polymer modulator I just showed you on this last slide, and that's the classic optical modulator that switches light very, very quickly at low power. And then we have Polymer Plus, where we put our polymers onto silicon photonics, which is on a silicon substrate. And that's what we call additive. And on the right-hand side, we have a design called the polymer slot, which has it's called tiny because it is the smallest form factor that can go on an integrated silicon photonics platform. And so what we're showing here is not only do we have natural integration with big foundries, we can turbocharge your silicon photonics integrated photonics platforms with our polymers, and so make a very competitive, very high performance platform that's really going to change the way data is being sent on the internet. In fact, when you look at the polymer attributes vis-a-vis commercial semiconductor competitive technologies, you can see on the top part of this graph, these are spider charts. And if you can cover the whole diamond of the spider chart, then your technology is much better. And so you can see in blue in the top, you've got silicon photonics. In green, you've got indium phosphide. In red, you've got lithium niobate. In purple, you've got barium titanate. And in the gold color, you can see the performance of the polymer actually covers pretty much most of the diamond. And so these are the technology strengths and weaknesses. And our polymer technology platforms are impressive and attractive. In fact, if you look at some recent technical performance, and this is optical bandwidth, this is actually the performance of the optical switching of the polymer modulators. You can see our lightwave polymers are over 100 gigahertz in performance on the 3 dB bandwidth. And that compares very nicely to technologies such as silicon, lithium niobate, and indium phosphide. So our polymer modulators outperform competitive semiconductor technologies, which is really exciting too. And our route to maturity and volume, this is using the technology readiness level scale. I've shown this slide before. It just shows you that we are in the prototyping and piloting stage. And as I've indicated in earlier presentations, we are preparing ourselves for the orange arrows, which are manufacturing. And that means that we have to start thinking about working with big silicon foundries because they really have the volume scale for mass commercialization. You can see that in this graph here. This is our polymer business roadmap. And you can see I've underlined in red in the center of this graph, foundry partnering. So our current engagement includes foundry partnering over and above customer interaction, testing, and evaluation. And this foundry partnering is really critical if you want to get scale quickly and efficiently in the marketplace today. So let's really talk about foundry scaling. And so one of the interesting things about photonics, silicon photonics in general over the last half decade is that these big silicon foundries are now, and these are just a sample of some of the silicon foundries you'll find around the world. These foundries are hungry for the opto business. They want to work with silicon photonics. They see the new upside of running many more wafers through their fab, because this is what foundries do. They run wafers through their fab. And the PDKs is the process development kit. In simplistic terms, that means it's their recipes to run the wafers through the fab. Their PDKs will drive the integration of photonic platforms in their foundries, and the drive to larger format wafers like 200 and 300 millimeter wafers allows the silicon photonics, the photonic integrated circuit cost and volume to be scaled effectively for mass commercialization. And this is really exciting too. And so in terms of our technology roadmap, you can see we put silicon photonics integration with Foundry PDKs on the lower horizontal bar. But the big takeaway from this slide is that there's a number of words I've used on the left-hand part of this slide, and that's unique chemistry and materials, unique chip design, unique high-speed performance, and unique polymer plus PIC platform. Our technology roadmap in general emphasizes our unique value to the industry, and that's what's going to make the change. If you've got a disruptive technology that's really going to change the internet, you've got to have some uniqueness, and you've got to be able to protect that with a very strong patent portfolio. And so partnering with silicon foundries, that means that we have to include our polymers into the Foundry PDKs. And the PDKs, as I've just indicated, it's the recipes, it's the library, the set of building blocks that these big foundries use. And this is a perfect vehicle for our polymers. Our polymers are actually created in our facility here. We can scale the chemistry, but we have a small fab here. So we really have to work with the big foundries to scale up and go to mass volume. And the processing that's required for making the polymers is actually quite standard, and you find it in the big foundries like the dry etching, the wet etching, the deposition of metals, and so the photolithography. These are all standard techniques that you find in these foundries. So the transfer of our technologies to the big foundries is going to be straightforward. And this is the route we are taking today. And of course, this is a very happy photograph of myself receiving the Optical Integration Award at a big international conference in France in September earlier this year, the European Conference of Optical Communications. And I'm very proud to hold the trophy on behalf of the company. So in terms of leadership, we have a very experienced management board. And one of the things that comes through from this board of directors is the very deep and knowledgeable technology experience from folks at the CTO level of huge multinational public companies that really understand the dynamics of the technology we have, as well as the customer base and how to position our company for success in the future. And so a very experienced, very deep and knowledgeable technology board. And in fact, we've complemented that with a technical advisory board with some of the smartest technologists that you can find in the world. And they're not just fiber optic communications experts. We have folks who have experience like Dr. Chesler with Illumina, microfluidics and genomics, as well as Dr. So, who's had experience with OLEDs, organic LEDs. And this is a polymer technology that's different from ours, but it's also been very successful from a commercial volume standpoint, as well as Dr. Hard and Dr. Umbach, who are very experienced in the fiber optic, laser and communications, high-speed design fields. And so if you look at the types of experience we are seeing here, we want to make sure that we're going in the right direction, and we're going to position our technology to be completely disruptive and ubiquitous across the internet. So in summary, we are certainly partnering for success. Our technology platform is working to scale the internet structure. We have an enabling technology to do that. It's designed to switch light very, very quickly at very low power, and today to transmit data at very high speeds across the internet, which is essential for the data communications, the data centers, telecommunications markets today. And we're leveraging our internally engineered and proprietary electro-optic polymers into very fast photonic devices called modulators that switch light very quickly. And as I've indicated, we're working with multiple foundries, packaging partners, transceiver partners to position Lightwave Logic, our company, for future high volume production. And we have technology evaluation underway. So we're leveraging with our partners to commercialize our technology in polymers. And this is a really exciting time for us. And I think it's a really exciting time for the internet and the whole environment as well. Thank you very much. And I'll leave you with the final slide, which our investor relations contact, MZ Group. Thank you very much.